Hey guys, and welcome to week 2 of the St. Edward High School Algebra and Enrichment program. Week 1 went awesome. You guys sent in a bunch of different things when we were looking at linear equations, graphing them out on Desmos. You guys came up with your own businesses. We're actually going to continue that a little bit more throughout this week as well. So kind of keep your businesses in mind as we continue going through this, and we'll be using those to kind of compare them to one another and even grow upon different thoughts and different places that you can use this new concept in the real world. Now, some of you might have seen this concept already. We're going to be working on systems of equations this week. Today specifically, I'm just going to be going through the three different ways in which we solve systems of equations. And I will also be going through a couple more videos on Wednesday and Friday for you guys. And don't forget that Tuesday and Thursday, we're going to have our Google meeting at 7 p.m. So don't forget that we do have that. I will send out the link to you guys tomorrow. I'll send it out. I'll actually include it in this email as well too, just in case you don't see it tomorrow, but I'll send it out a couple times just to make sure that you have it. If you have any questions, like I said, please make sure that you email me and we'll make sure that you get on. But we all should be all set for this week. But we're specifically going to be looking at today the substitution, elimination, and graphing methods of solving systems of equations. Systems of equations, the main concept of that is looking at two different equations and figuring out where they intersect, where they meet, where both of them have the exact same point on either a graph or just any type of question that you can deal with it. There's a whole bunch of different things that businesses and real-world applications use systems of equations with, and we're going to be looking at a ton of those this week. So as I go through this, if you have any thoughts or anything like that, make sure you write them down, any questions that you have, because we'll be going through a lot of those tomorrow. If you do have a question, make sure that you ask it tomorrow, or you can write me an email and I'll be more than happy to answer those questions for you guys. But today specifically, we're going to be going through these three different ways of solving systems of equations. Now the first one is substitution. What's nice about substitution, elimination, and graphing is that I like putting all three of these in 5 different steps. So there's going to be 5 steps that you can easily remember how to do different things like substitution, elimination, and graphing. But specifically here, substitution, the main concept of substitution is just plugging one function into the other. So you guys are going to go through, you'll have 2 different equations, and you're going to have to solve where they meet. So whether it's a word problem, something you guys are comparing with one another, you're going to have to figure out when this number meets this number and at what price or at what number or at whatever it could possibly be. So for example, I'm going to write down the steps as I go through this to maybe help you guys out. So for substitution, the first step is that we want to get x or y by itself. Okay, so we want to get x or y by itself. And in this case, we have step 1 already done. We have a y by itself. We have y is equal to 2x plus 3. It doesn't matter in the other equation. All we needed is in one equation that is set by itself. The second step is the main step of substitution, is we're just substituting it in to the other equation. So I'm going to take this y and I'm going to plug it into this y. Okay, so because y is equal to 2x plus 3, I can plug in 2x plus 3 for y there. So it would look something like this, 2x minus 4 times, instead of y, now I'm going to write out 2x plus 3. Okay, is equal to 24. So notice that this line and this line are the exact same thing, except for instead of writing y, now I'm writing 2x plus 3. And that's the whole substitution step. The third step is just going through and solving for x. And so the third step is solving for your remaining variable. And so whether you plugged in an x or you plugged in a y, you're just solving for your remaining variable. So in this case, as we go through and solve it, we multiply through or distribute it through. We get 2x minus 8x minus 12 is equal to 24. And then you combine the 2x minus 8x is negative 6x. I'm going to add 12 to both sides. Is equal to 36. Divide both sides by negative 6. and you get x is equal to negative 6. So I have my x value. I know that both of these equations are the same when x is equal to negative 6. Well, we're looking for a coordinate, so instead of just an x value, we also want a y value. So whenever we solve and we get that value, all we do is we actually substitute again it back in so that we can go through and solve for y. So I'm going to take this question, or part of the question that I boxed, and instead of x, I'm going to plug in negative 6. So I'm going to have y is equal to 2 times negative 6 plus 3. So you get negative 12 plus 3, which is equal to negative 9. So I have an x value, I have a y value, so my answer, which is step 5, is always a coordinate x comma y. So my x is negative 6, my y is negative 9. So at the coordinate negative 6 comma negative 9, these two equations are actually the exact same. So you can think of it on a graph, or you can think of it in terms of whatever you want, whether it's a certain business or a certain number of things, or anything that you can possibly think of in the real world that we can use these two equations together with. These two equations intersect each other at negative 6, negative 9. So those are the 5 steps of substitution. Get x or y by itself, substitute, solve for the remaining variable, substitute it back in, and then x comma y. And those steps just are right here. Step 1, step 2, substitute it in. Step 3, solve for x. Step 4, substitute it back in and solve for y. And then step 5, you have your coordinate. Okay, if you have any questions on substitution, make sure you write them down. I'll be answering them either through an email from you, or I can answer them tomorrow during our Google Meet. The second way is through elimination. Now this way is a little bit trickier, but I do think this is actually a faster way for those of you like going through different ways of looking at math. Elimination looks at using the concept of equality to help cancel terms in both equations. And there's 5 steps here as well too to kind of make it a little bit easier. So for example, if we have something like 2x plus 6y is equal to 4 and x plus 8y is equal to 3. My first step is usually set up for us. I call the first step, line them up. And line them up. So if we line up the x's, the y's, the equal signs, and the numbers, we're all set for using elimination. Just like how here, the first step was to get y by itself, so we wanted to set it up so we can use it. In this case, we want to line them up. We want to get the x's, y's, numbers, and equal signs together. Now the second step is we want to use what we call the elimination step. Okay? In this case, we want to eliminate either an x or a y. Now in this case, you don't see a way that we can possibly do that just yet, because by putting them together, you're still going to have x's, you're still going to have y's. So what I'm going to do is I'm going to multiply this second equation by 2. Oh, sorry, by negative 2. Why? Because when I do that, my first equation will stay the same, 2x plus 6y is equal to 4. But now my second equation, when I multiply this in, you get negative 2x plus 16y is equal to negative 6. And then when I go through and solve this, what's actually going to happen is when I put these two equations together by adding them, the 2's cancel and we're left with 22y is equal to 4 minus 6 is negative 2. So now we have an easy way to solve for y. You divide both sides by 22 and you get y is equal to negative 1 over 11. So we have a y value. Now I can easily solve for an x value. I'm just going to take this and plug it into here. Okay, so my third step was to solve for y, or solve for remaining variable. And now my fourth step is to substitute it back in. So once I used my elimination step and I eliminated those x's, now I have this y value, and I'm going to plug that in. You get x minus 8y. Well, instead of y, I'm going to use negative 1 over 11 is equal to 3. It's okay to have fractions. If you struggle with fractions, it's something that you should work on, hopefully. It's because they are seen a lot, especially once you get into high school math. We use fractions a lot. So you get x plus 8 over 11 is equal to 3. When you subtract 8 over 11 from both sides, remember 3 is 33 over 11, so 33 minus 8 is 25, so x is equal to 25 over 11. Once you've substituted it and solved for your other variable, just like the last one, we want our answer as a coordinate in x comma y. Okay, so we can take this and create a coordinate with it that is 25 over 11, comma, negative 1 over 11. Okay, so for those of you that have done elimination before, that's good. Hopefully this is a good reminder and refresher. For those of you that haven't, I have also included a couple resources in your email that you can go through and look at to help you out a little bit more with elimination. But this is another way to do it. You can always use either one or the other. I'm never going to specifically say you have to use substitution or you have to use elimination. Some teachers might ask you to know both, but some people really like to do elimination. Some people really like to use substitution. So you can kind of go through and do either one that you want. But the 5 steps here, we're line them up. We want our x's, y's, numbers, and equal signs to line up. The second step was to somehow get the x's or the y's opposites of one another. So we have 2x and we have negative 2x. Those are opposites, so that when we add the equations together, the x's cancel. So our second step was to get x's or y's so that they cancel for one another. And we use different multiples to be able to do that. Sometimes it's nice and it's already set up for you. The third step, once we do that, we solve for the remaining variable. The fourth step, we plugged it back in and we solve for the other variable. And then the fifth step, you just get a coordinate where the two intersect. Now these might get a little bit trickier, but it's nice once we're dealing a little bit more with prices and businesses and things like that. You'll notice that you'll get decimals and you can kind of leave that into 2 decimal places as you're looking at money and things like that. All right, and then the last one that we look at is graphing. And this one's the easiest if it's set up well for you. Sometimes it's hard to see if you get fractions and decimals on a graph, but I think there are 5 really simple steps to be able to go through in solving with graphing too. The first one that we say is we want to get y equals mx plus b's. And we did this in the first week. We tried getting, having linear equations. We want to have 2 y equals mx plus b's, which usually are given to you. We have the slopes, we have the y-intercept, so I can easily go through and put these on a graph. So my second step is to graph the first. Okay? It's to graph the first equation. So you start at negative 3, and we have a slope of 2. So you go up 2 over 1, up 2 over 1. And now you can graph this out so that we have a straight line. And that's this first one. I'm going to use a different color for the second one. So we have negative 3 plus 12, and I use that for the step 3. Okay. Step 3, I graph the second one. I start at 12, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I go down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. So we get a graph that looks like this. So we have a point where these two go through and intersect. All right, so what we want to look at is, well, where do these two intersect? And that's what step 4 is. We want to find, where they intersect. And this is just looking at the graph, looking and seeing, all right, well, where do these two intersect? Well, you can see that it intersects there where I marked, and then figuring out what point that is. Well, this is 3, comma 3, it looks like. We have 3, comma 3. And we want to see if that's the correct intersection. So step 5 is just to check it. So we want to check and make sure that 3, comma 3 works for both of these graphs. If I plug in 3, comma 3 into both of these, you get 3 is equal to 2 times 3 minus 3 when I plug in 3 into x and y, which you get 3 is equal to 6 minus 3, which is 3 is equal to 3. So that checks. And then you plug in 3, comma 3 into the second one, which is 3 is equal to negative 3 times 3 plus 12. Negative 3 times 3 is negative 9. Negative 9 plus 12 is 3. So that checks as well. So that means that our coordinate where these two intersect is the coordinate 3, comma 3. And a lot of people think, well, that's a lot easier than substitution and elimination, which it is. If you're able to set those up that way really quick, yes, it's pretty quick to go through and graph it and see where they intersect. The problem lies in something like this last elimination problem that we just did, where it's really hard to see on a graph the coordinate 25 over 11 comma negative 1 over 11. So if the answers are whole numbers, sometimes it's really easy to see, but sometimes it's not, because if the number, or it's not if you had fractions or decimals or even really big or small numbers. So those are the three different ways that we go through and graph them. There are a couple more resources in your emails that I sent with each of them, so you can find a different way to use graphing, to use elimination, to use substitution, to help you go through and solve these systems of equations. So look at those resources, just kind of go through them, make sure that you're all set with this, because as we go through this week, if you have any questions on it, please, please, please let me know, and I'll be able to go through and help you out with those. We can meet separately through a Google meeting if you want to, and just to make sure that you feel comfortable with that material. Please bring any questions that you have about any of these three to the Google meeting tomorrow at 7 p.m. I'll send out the link to that as well. And last but not least, obviously, go Eagles. Please, I know this is, you guys are right before Christmas break, in between Thanksgiving and Christmas, so I know it can be a little stressful time, but if you need anything, let me know. But other than that, I hope you guys have a great day. I hope all you guys are staying healthy, and other than that, have a great day, and I'll see you guys tomorrow on the Google Meet. We'll see you.